Our first function to write is a function called miles to feet. It accepts one floating point number representing a number of miles, and it returns a floating point number representing the number of feet. There are 5,280 feet in a mile, so to calculate the number of feet, you have to take the number of miles and multiply by 5,280. So it's going to be a relatively short, simple function. Let's flip over here and let's start writing. So our first function is going to be miles to feet, and we're going to pass in the number of miles. I'm going to let Python know that this is going to be a number, so I'm just going to give it a default value of 0, and I want to take the number of miles, which is the argument that was passed in, and multiply it by 5,280 and return that. So you could do something like this: feet equals miles times 5,280, and then return feet, and that should work. Let me flip over here to my function calls so I don't have to type them myself, and we'll leave a little bit of space here. We're going to put the functions at the top and we're going to put the calls at the bottom. So this should give me 5,280. 1¼ miles should be 6,600 feet. Let's go ahead and save this, and we're going to save it as review 2019. Save it. Now let's run it, and I don't want to see this again. And I get 5,280, and I get 6,600. So notice this was returned as a floating point number because a floating point number was passed in. This was returned as an integer because an integer was passed in. But that's a minor detail. We don't really care about the type that's returned as long as we're getting the right number here. Our second function is to be called time in seconds. It will accept an integer representing hours, followed by an integer representing a number of minutes, followed by an integer representing a number of seconds. We are supposed to compute and return the total number of seconds in the three numbers combined, which will also be an integer. So there are 3,600 seconds in an hour, so the hours here would have to be multiplied by 3,600. There are 60 seconds in a minute, so the number of minutes would have to be multiplied by 60, and then the number of seconds is just added on to that total. So let's write our another function here. And let's do nice descriptive names. So I need to multiply the hours times 3,600, add on the minutes times 60, and add on the number of seconds. And that's the number I want to return. Now I could put it in a variable and return the variable, but that's just an extra step, so I'm just going to say return that. And now if I flip over and borrow this print instruction here and paste it in, now if I run the program, I should get 3,723, and this is the one where I forgot a parenthesis, so let's try that again. And we get 3,723. Our third function is called rectangle perimeter. It will accept a floating number representing the length of a rectangle and a float representing the width of a rectangle, and return a float representing the perimeter. So the perimeter is the width plus the length plus the width plus the length, and that'll get you all the way around the outside of a rectangle. So let's go over here, and our function is going to be called rectangle perimeter. We're going to pass in a length and set that equal to 0, and we're going to pass in a width. Set that equal to 0 as well, and put a colon on the end. And now I want to return 2 times the length plus 2 times the width. So I can also do that, just a single return statement. Okay. And it looks like I did spacing on one of these and not on the other, so let's make them look consistent. And now let's flip back over here and let's copy that. And let's paste it in down here at the bottom. And need to be on another line there. So, looks like I forgot another parenthesis on this one as well. If I have something with a width of 5 and a length of 10, 5 plus 5 plus 10 times 10 plus 10 plus 10 is 30. That's the answer I should get when I run this. Let's go ahead and run it. And we get 30 for our perimeter. Our next problem is related. It's to find the area of a rectangle. We're going to accept a floating point number representing the length and a floating point number representing the width. And we're going to return the area. And all this is really going to do is just multiply the two numbers together. So let's flip over to our Python editor and let's write our function definition. It's going to be called rectangle area. And we're going to pass in a length. And we're going to pass in a width. Oops. And what we want to return is just their product. So if I go over here now and borrow this instruction, which also has a missing parenthesis, I should get an area of 50 for a rectangle that's 5 by 10. So let's run this. Our last output should be the number 50, and it is. Our fifth problem is to find the circumference of a circle when given the radius. And the function is 2 times pi times the radius, and we're going to assume that pi is equal to 3.14159. So let's flip back over to our Python editor. And we need to define function. The name of the function is circumference. And I'm going to pass in the radius. And we want to return the circumference. So it's 2 times pi. And we said we'd use 3.14159 for pi. And multiplied by the radius. It was called r in the example, which is the way it's frequently referred to in math discussions. But I decided to call it radius here, which is more readable. And if I call it radius here as an argument, then I have to call it radius here. So let's go ahead and run our program now. And before we can run it, we have to get a sample print that calls the function. So let's go down here. So we should get 62.8318. Let's go ahead and run that. And we get 62.8318, which is exactly what we were supposed to get. Our sixth problem is to write a function called circle area that will compute the area of a circle. And the only thing you need to know is you need to know what the radius is. So that's the argument that will be passed in. And we will return the area of the circle. So the formula is pi times the radius squared. And this is going to have to be translated into Python. So let's write our function definition. It is called circle area. I'm going to pass in the radius. And what I want to do is my formula was pi times the radius squared. Well, we don't have pi. Put this in just a return statement. We have 3.14159 times the radius squared. So I can either do radius times radius, or probably the easier way to do it, 2 asterisk is for raising a number to a power. I want to raise that to the second power. So we've got a function here that calls circle area. Let's paste that in, and I selected way too much there. I just want this. Let's do it. See if we can get this again. Control C, and let's go over here and paste it in. Okay. Again, I seem to have forgotten another parenthesis on the end of this. So the area of a circle that has a radius of 10 should be 314.159. Let's go ahead and run that and see if our last number is 314.159, and it is. There is also another way to deal with pi, and that is to import math. Then whenever I want to refer to pi, like down here, I can just do math dot pi, and that is a constant, and it will give me more digits of precision than just the 5 digits that I have right now. So let's so we're doing circle area. We should get the same answer when we do this, but we may get a few more digits in the answer, and we do. Our 7th problem is to write a function called future value, and it will accept a dollar value that's going to be invested, an annual interest rate, and the number of years, and it will return the future value of the dollar invested at the given rate. So this is basically compound interest, and we want to, P is the principal, so that's our dollar amount, multiply it by 1 plus the 0.01 times the rate. The rate is going to be, like, this is 10%, so we need to multiply that by 0.01 to make it 0.1, which is the way 10% would be expressed. We're going to have to put an asterisk in here, and we're going to have to do our double asterisk to raise it to the y power. So I'm just going to copy this formula right here, and it'll be interesting to see how that y gets copied over. So let's give this one a try. The function is future value. We're going to pass in the principal. We're going to pass in the annual rate. And we're going to pass in the number of years. Okay. So let me paste in. So I want to return P times 1 plus that times R. Let's put some spaces in here. Okay. So the multiplication will get done first, which is what I want. And then I need to raise this to a power. And I don't have a variable called y, but I have a variable called years. I've got to make sure I do the translation here. And R is not one of my variables. I've called it annual rate in my argument list up there. And I don't have a variable called P, but I have one called principal. Just put a few spaces in there to kind of spread things out. And now I want to call that function. And I'm going to pass in $1,000, 10%. This is a whole number 10, so to make it in 10%, you have to divide it by 100, or another thing to do is basically the same thing, is to multiply by 0.01, which is what we're doing, and then 5 is the number of years. Okay, so we should get 1610.51 if we do this. And we do, and this is actually what I got the other time I ran it, but when I was making up the answers here, I left all those extra zeros off. Our next function is to be called distance. It's going to accept 4 integers, an x-coordinate and a y-coordinate for one point, and an x-coordinate and a y-coordinate for another point. And it's going to return the distance between the 2 points, x0, y0, and x1, y1. So I've got the origin is my first point, 0, 0, and then I'm going over 4 and up 3, which you may recognize as 2 of the legs of a right triangle that give a hypotenuse of 5, which is the distance from the origin to that point. So I want to take the square root of, I'm going to copy this again here. And let's write a function now. We are passing in, we're going to call it x0, comma y0, x1, comma y1. And I should probably be consistent here and just initialize these. Okay. And then let's go down to a new line here. And let's do a return command. And then the square root of this number raised to the second power and this number raised to the second power. So let me see. Those two parentheses go together. These two parentheses go together. And if I click on this one, those two parentheses go together. Okay. So the question is square root a built-in function? And it is not. If I pause, there's a little yellow line there that may be difficult to see in the video. It's not all that easy to see right now, but tells me I've got an undefined name there. Now I know there is a square root function. It's in the math, and it's in the math library. And if I do math dot and sqrt is a function, and I got it twice now because I clicked on it. So let's try this one out. Let's flip back over and take this print command, and let's paste it in at the bottom here. So we should get an answer of 5, probably 5.0, because we're doing a square root. I think the square root returns a floating point number, but we'll see. Let's run it, and we do get 5.0, so it returns a floating point, not an int.